A very good morning, students. So in today's class, we will be seeing about that electromagnetic fields. So one of the important topic for the GATE classes, and you will be seeing about electrostatics. So in the electromagnetic field, we have electric field and magnetic field are the main concepts. So in that first one, we will be seeing about that electrostatics. Basically, later on we can go for the next electromagnetic fields. So even though in the GATE topics they have started only with the electric fields the straight away due to line charge and different charges. This is the basic thing what you have to know. This is the basic thing what we have to know for electromagnetic fields. For electromagnetic field, this is very important thing. So you know the concept that electric field is depends on voltage and magnetic field depends on current. So the electromagnetic field mainly depends on voltage and current. So when you go for that electric field, it is given by the formula, basic formula E equal to V by D. E equal to V by D. Similarly, the magnetic field, it depends on current, and magnetic field is given by the formula H equal to Ni by L. H equal to Ni by L. That is the concept what you will be having there. Okay, where N is the number of turns, I is the current, and L is the length of the conductor. So the electromagnetic field mainly depends on the voltage and current. Voltage and current. So what are the main sources of the electromagnetic fields? We have that natural sources and man-made sources. So when you go for natural sources, you will be having lightning, thunderstorms. From that you will be getting the natural sources. So when you go for man-made sources, X-rays. So in the X-rays, you will be getting with the effect of that X-rays, we can diagnose our broken limb or anything. So that all comes under the man-made sources. And when you go for what are the effects of electromagnetic field, these are the basic effects, biological effects. Then high exposure of electromagnetic fields. In high exposure of electromagnetic fields, we will be having that high irritation, cancer, and all these things. Then when you go with the different coordinate systems, so electromagnetic fields we will be assuming in terms of the 3 coordinate systems. So in the mathematics you might have studied about that x, y and z. X, y and z. Okay, so x, y comes with the 2. Normally you will be having with 2 parts, x axis and y axis. That what we call it as 2 axis. But electromagnetic field always they will be determining in the 3 axis part. 3 axis part. Okay, so for solving the problems, we have to remember about that 3 axis part here. So we have different coordinate systems. So among that, the famous 3 is Cartesian coordinate system, cylindrical coordinate system, spherical coordinate system. Okay, whatever in the normal thing we are studying is about that Cartesian coordinate system. I vector, j vector, and k vector is what we have imposed, specifically imposed as ax, ay, and az. That we can have it as ax, ay, and az, or I vector, j vector, and k vector. So that's what you will be having there. That's what you will be having the Cartesian coordinate system. Okay, so x vector, sorry, I vector, j vector, k vector, that's what we call it as that x, y, z here. And these are all the simple things, the basic elements of the thing what we will be seeing there, what we have to know while solving the problems in the electromagnetic fields. Okay, so the x value, y value, z value, how it values will be? It will be from minus infinity to infinity. Then if you move a point in a Cartesian coordinate system from one point to another point, you will be getting differential length, differential volume, differential surface. Differential length, differential volume, differential surface there. Okay, so these are all the basic formulas that we have to keep in mind while solving the problems in the electromagnetic fields. Okay, so always dV will be the product of the coefficient of dl. dV is very simple, what we call it as differential volume. It will be the product of the coefficients of dl. Okay, that you keep it in mind. These are all the small shortcuts what you can have while solving the things in the gate exams. Okay, so if you remember dl, that one, from that you can have it as dv there. If you know the dl correctly, for example, you see the dl here, you will be having dxax plus dyay plus dzaz. So dv is nothing but coefficient of ax, coefficient of ay, coefficient of az. They are products. That's all. So you will be having dv dx and dx dy and dz. Okay, so similarly we can have with that area part. So in area part, if you are solving with the dsx, you will not get dx. You will be having another two coefficients, dy and dz. Like that, you should remember that. These are all simple shortcuts what we can have. Okay, similarly for dsy, what we can have it as, you don't have dy, you will be having dz and dx. Okay, and for dsz, you will be having with dx and dy. So for all the thing for dv and ds, the base is dl. If you write differential length correctly, it will be very useful to see about with the dv and ds there. Okay, make sure that dl is we are writing correctly in the part. So this one is for the Cartesian coordinate system. What we will be having the next one, what we will be having with the cylindrical coordinate system. So far, so in the lower classes, you might have studied only within your Cartesian coordinate system. However, in your basic engineerings, so you're all the triple and EC students, so you'll be studying about definitely about that electromagnetic fields and electromagnetic theory. So triple students might have studied about the electromagnetic theory, and EC students might have studied as a electromagnetic fields there. Okay, so they might have studied about these things. And when you are going to write the exam about that gate preparation, you might have remember when you are studying about the electromagnetic fields, you have to thorough with these three coordinate systems, because the problems they will not don't expect, they will be asking only with the Cartesian coordinate system. The previous one what we have seen about the Cartesian coordinate system, it is a basic system, and don't think they will be asking only from that system. They will be also asking from different Cartesian coordinate system and all these cylindrical and spherical also. So when you go for the spherical coordinate system, we have three axes like x, y, z. Here you will be having rho phi z, where rho is the radius which varies from 0 to infinity, and phi is the angle of deviation or angle of rotation, we can say 0 to 2 pi, and z is the height of the cylinder. The best example, the cylinder what we are using in your houses. But also you can have. So the cylinder will have the radius, and you can rotate the cylinder from 0 to 360 degree, and the height you can place it from minus infinity to infinity. Here once again, if the position is varied in a point of the cylinder from one point to another point, you will be getting dl, dv and ds. dl, dv and ds. Differential length, differential volume, differential surface. And most of the students, what they will be thinking is, for Cartesian system, dx ax plus dy ay plus dz az. Similarly, for cylindrical system, it will be d rho a rho plus d phi a phi plus dz az. It is not so. Okay, well, since we are dealing with an angle here, we have to clearly see about this thing. dl equal to d rho a rho d phi a phi plus dz az plus dz az. dl equal to what you will be having, d rho a rho plus rho d phi a phi plus dz az. Okay, so once you remember the dl properly, you can write dv and ds. So I have given the clue in the Cartesian coordinate system how to write dv and ds. Once you know about dl, we can easily write dv and ds there. Similarly here also once you know about that dl and dv, once you know about dl and dl, you can write about that dv and ds here. dv and ds. This is about the thing what you will be having with that cylindrical coordinate system. Cylindrical coordinate system here. Then we will be having with the spherical coordinate system. Then you will be having with the spherical coordinate system. So assume a ball. So in a ball you will be having the radius and the phi and theta. Theta is the subtend angle what you can have, and phi is the angle of rotation. And phi what you will be having with that angle of rotation. Okay, you can see that one theta, we can say it as the half angle. That half angle will varies from 0 to pi. 0 to pi. And phi it will be varying from 0 to 2 pi there. 0 to 2 pi. Similarly, if you move a point from the sphere from one point to another point, you will be getting dl, differential length, differential volume, differential surface. Differential length, differential volume, differential surface. So differential length, once again here you will be having it as dr ar plus r d theta a theta plus r sin theta d phi a phi plus r sin theta d phi a phi. So the coefficients of AR, A theta and A phi will comes on dV. Coefficient of AR, A theta and A phi will comes on dV. Similarly, for DSR, the coefficients of A theta and A phi will come. For ds theta, coefficients of AR and A phi will come, and for ds phi, the coefficients of AR and A theta will be there. So similarly, we have to take it for all other things there. Then we know about the transformation of coordinates. So these are all the basic formulas, so that you have to keep it in mind while transferring one point to another point. Okay, we have three coordinate systems: Cartesian coordinate, cylindrical coordinate, spherical coordinates. So when you transform a point from Cartesian to cylindrical, how we can, I am given it as a, so say for example, I have given it as 2, 3, 5. I am having the point in a Cartesian coordinate as 2, 3, 5. It is in Cartesian coordinate. I want to convert them into the cylindrical coordinates. So this kind of formulas we have to adopt that. Similarly, we have given the list for all the coordinate systems. So we have to thorough with the all coordinate systems. So how many conversions we have? We have 6 conversions. We have 3 coordinate systems: Cartesian, cylindrical, spherical. So we have, how many conversions we can have? We can have 6 conversions. So that's what we are seeing on this PPTs then. And we have given with a model problem here. You can see that one. So you will be having the represent the point 0, 1, 1 in the Cartesian system into spherical coordinate system. You want to convert that point into the spherical coordinate system. Okay, so Cartesian coordinate system, we have x, y, z. When you want to convert them into spherical coordinate system, we have to find out r, theta and phi. R, theta and phi. So for r, what will be the formula? It will be having root of x square plus y square plus z square. And for theta, it will be having cos inverse of z by r. And for phi, you will be getting tan inverse of y by x. Tan inverse of y by x. So if you convert all these things, you will be getting in the final format. Okay, well, this is the basic thing what you will be having there. Then if they are given with the negative value, what we have to do? Say for example, this model problem. So the last model, all the things are positive, 0, 1, 1, what we have it as a positive value. But here you see here, in this problem, they are given as minus 2, 6, 3. Minus 2, 6, 3. So we want to convert them into cylindrical and spherical coordinate system. Cylindrical and spherical coordinate system. Okay, so what we will be having is in cylindrical coordinate system. what you will be having it is in the cylindrical coordinate system. What is the formula? Rho, phi and z. Rho equal to root of x square plus y square. Phi equal to tan inverse of y by x and z equal to z. That is the basic formula while you are converting from Cartesian to cylindrical. Rho equal to root of x square plus y square. Phi equal to tan inverse of y by x and z equal to z. Okay, so here you can see rho equal to x square plus root of x square plus y square. So the answer you will be getting the positive value. But for phi formula you see here tan inverse of y by x. So if it is tan inverse of y by x, you will be getting tan inverse of 6 by minus 2. So what you will be getting it as minus 71.56 degree. Minus 71.56 degree there. Okay, always angle cannot be negative. Angle cannot be negative. So for that what we are doing is we are adding 180. We are adding 180. Okay, so angle is negative plus 180. What you will be getting it as 108.44. So phi equal to minus 71.56 plus 180. What you will be getting it as 108.44 there. Okay, so you will be getting the Q value. So and Z equal to Z, whatever you have there. Okay, while substituting angle, always take care if the angle is getting negative, you have to add 180. You have to add 180. That is the basic thing what you should know there. Similarly, the next one, we are converting them into spherical coordinate system. Cartesian into spherical coordinate system. Okay, here also you see here we are finding out r theta and phi. R theta and phi. So for phi you are getting the angle as negative. For phi you are getting the angle as negative. So what we are doing there, we are adding that angle with the 180. So phi equal to minus angle plus 180. What you will be getting it as 108.44. Okay, so that's what you will be seeing there. So these are all the basic things you think. You might have come across about the vector calculus. I don't want to more discuss about these points. Okay, straight away we can go for that projection of vectors. And about the problems along this one here. About the basic dot product of vectors. I have given with A vector and B vector. If you want to find out the dot product, we have to straightly multiply the coefficients. Okay, so the 2 into minus 1 plus minus 3 into 2 plus 2, 4 into 2. That you will be getting as dot product there. Then about the projection of one vector over another vector. I have given with the two vectors for you. If you want to go with the projection of vectors, if you want to go with the projection of vector, projection of A on B. Okay, A vector equal to 10ay plus 3az and B equal to 5ax plus 4ay. Projection of A and B, we will be having this one here. These are the basic things what you will be having. So now we can straight away go for that about the gradient, divergence and curl. And these are the basic things related with your electromagnetic fields there. Okay, so transformation of vectors concept also will be having that important part, but along with that can have with the gradient, divergence and curl here. Okay, so the gradient is nothing but the del operator. We will be having with the del operator here, and this is the gradient what you will be having there. So gradient of a scalar field, always it represents about the magnitude and direction of the maximum space of rate of change of that function. Say for example, if you are having that any scalar field and if you want to represent them into vector, what we have to do is we have to take gradient. We have to take gradient. Okay, so for any scalar field, if you take the gradient, it will give the answer in terms of the vector. Okay, that means for any scalar field, if you want to find out the direction, what is the direction of that vector, direction of that field, we have to, what we have to take? We have to take gradient. Okay, so gradient of the scalar field is we have been represented with three formats. As I told, we have three coordinate systems: Cartesian coordinate system, cylindrical coordinate system, spherical coordinate system. We can express with the three coordinate systems there. So you will be getting del A, del B, and del C there. You can see that one for different coordinate systems. For different coordinate systems, what are the things we have? We can see the formula. The formulas also will not be constant. Depends upon the type of coordinate system you are using, it will be getting varied. Okay, we have to thorough with these formulas also. Okay, so don't think this gradient, divergence, and curl. What you are studying, it will be simply with the starting itself. It will be very much helpful while solving the problems in the electric field and in the magnetic field concepts. The magnetic field concepts. So in the mathematics, you might have studied only with the Cartesian system. But in the EMT and the EMF for the EC students, they might have studied in the, definitely they might have come across, you might have all come across in the three coordinate systems. Okay, so without this three coordinate system, there is no existing EMT there or EMF. So you can see a normal model problem relate with that gradient. You can see that one. We have to find the gradient of the scalar field P of root 2 comma pi by 2 comma 5 defined in the cylindrical coordinate system equal to 25 r sin phi. Okay, in some of the books they might have used rho, in some of the books they might have used r there. Don't get confused in that one. Okay, depends upon that author, they might have pronunciation, they might have used rho for radius, and some of the books they will be represented r. See the points. On seeing the points itself, we can determine whether it is a cylindrical coordinate system or Cartesian coordinate system or spherical coordinate system. So for spherical coordinate system, what will be having r, theta, and phi. For cylindrical coordinate system, what will be having that rho, phi, and z. Okay, so when you have two values with the angle in between, two values with the angle in between, it is cylindrical coordinate system. If we have got two values with the angle in between, it is called as a cylindrical coordinate system. If you have two angles, then it is nothing but you will be having as spherical coordinate system. R comma theta comma phi. R comma theta comma phi there. Okay, see in that concept, sir. See in that concept clearly there. Okay, so here you will be having with the thing here I a equal to 25 r sin phi. Okay, we have to take the del A gradient. Okay, so dou A by dou R into AR plus 1 by R dou A by dou phi into A phi plus dou A by dou Z into AZ. We are finding out dou A by dou R, dou A by dou phi, dou A by dou Z separately. You will be getting del A. So in that del A, we are substituting the points there. R value is root 2, phi value is pi by 2, Z value is phi. Then if you substitute there, you will be getting the answer. You see the question there, A equal to 25 r sin phi, and you see the output here, del A equal to 25 AR vector. What is that meaning that? So the input is scalar and output is vector. So what's the difference between scalar and vector? Scalar will be having only magnitude. Scalar will be having only magnitude, but vector will be having magnitude along with the direction. Magnitude along with the direction, we call it as the vector. If we have only magnitude, it is called as scalar. Magnitude with the direction is what we call it as vector there. Okay, so that what we have told there, already we can see that one. So gradient will give the gradient of the scalar is a vector. The first statement we can see that one. Gradient of the scalar field is the vector, which gives magnitude and direction of the maximum rate of change of that function. What you are doing, the maximum rate of change of the function, we differentiating that point. That's what they are told there. Okay, It's very important concept there. So we have to remember with different coordinate systems. So what I have shown the model is for the cylindrical coordinate system. Similarly, we have to see it for that Cartesian coordinate system, cylindrical coordinate system, sorry, spherical coordinate system also. So the next one, what we'll be having with the divergence. Okay, so the divergence is nothing but what is the net outward flux in a closed surface. What is the net outward flux in the area is what we call it as the divergence. Okay, so for example, we are all fully that electrical and electronic students. We will be having that one. So you know about the solenoid. I am passing the current through the solenoid. What happens there? The fluxes will be revolving around that solenoid. In a pure solenoid, the fluxes should not get diverges. Okay, it should form the closed path. The fluxes should form the closed path. Fluxes should form the closed path. We say that divergence of the fluxes is zero there. Divergence of the fluxes is zero. Okay, so all the fluxes will be flowing, making the closed path. Okay, so the divergence, what it tells us, how much the net flux per unit volume it sinks out. A pure divergence, so a pure divergence, we can say that one, how much the vector or the field diverges or converges from that point. That what we call it as physical meaning of divergence. Okay, how much the field represented is diverges or converges from that point. For that example, we are given with the solenoidal field. Just now I told you about that solenoidal field. So in solenoidal field, what happens there? All the fluxes will be getting rounded. It will not be getting deviated. It will not be getting deviated. So that what we have it as a solenoidal field. That's what we have it as a solenoidal field. So similarly for divergence, what we'll be having it as, we have three sets there. For Cartesian system, cylindrical system and spherical system. And we can say the interesting factor that is important gate question they can relate you. How the gradient and the divergence are related. How the gradient and divergence are related. Both are inversely proportional, we can say that one. Can not say with that directly with that inversely proportional. The concepts will be reversed there. So in gradient, what is the input? Input is scalar, output is vector. In divergence, what happens is input is vector, output will be the scalar. Output will be the scalar. So for the solenoidal field, we can say how much field is getting, how much, what is the value of magnetic field that is getting inside. Okay, so a perfect solenoidal field. A perfect solenoidal field. So before that, we will be going with these concepts. So these are the formulas relating with the different coordinate system. For Cartesian system, for cylindrical system and spherical coordinate system. For each system, the formulas will be getting different. The formulas will not be same what is seen for the Cartesian coordinate system. Sir, how we can identify whether the system is Cartesian, cylindrical or spherical system on seeing the question itself? Just to see the vectors. Just to see the vectors. If the vector is ax, ay, az, they are I, j, k. It belongs to the Cartesian coordinate system. If the vector is a rho, a phi, a z, then it belongs to the cylindrical coordinate system. If the vector is ar, a theta and a phi, then it belongs to the spherical coordinate system. Then it belongs to the what will be having, it is the spherical coordinate system. Like this, we have to differentiate about three coordinate systems. Okay, so with this they can ask, they will be giving you one vector and asking you to find out whether it is solenoidal or not. For solenoidal field, what is the condition is, this one is the condition, del dot A equal to 0. del dot A equal to 0. For solenoidal field, what will be having that? Del dot A equal to 0. If the divergence of the vector is 0, divergence of the vector is 0, then we can say that vector is purely solenoidal. That vector is what will be having as purely solenoidal. Okay, well, like that they will be asking you the problems, the gate parts. So these are all the simple problems what we can say with the thing. Okay, well, we can see that one. Divergence of this vector field q equal to rho sin phi a rho plus rho square z a phi plus z cos phi a z. A rho a phi a z. These are all the things what we will be having there. We want to find out divergence. Divergence means, so as I told, how they are not given cylindrical or spherical or Cartesian system. Just they are given the question. On seeing the question, how we can identify the system? We have to see the vector, don't see the coefficients. The coefficient will be numerical value or any alphabetic value. Just to see the vectors. Vectors is a rho a phi a z. The vector is a rho a phi a z. Then it's nothing but corresponds to the cylindrical coordinate system. Then it corresponds to what will be having it as a cylindrical coordinate system. Okay, so del dot q equal to, you will be having for cylindrical coordinate system, what is the formula? We have to substitute the coefficients of q rho, q phi and q z, and we have to find out the thing. So proper differentiation, we have to do the partial differentiation, we will be doing that, and we will be finding out that thing. And you can see that thing here, input is vector, output is scalar. Input is what will be having as vector, output is scalar here. Output is scalar. So q equal to rho sin phi a rho plus rho square z a phi z cos phi a z. So the del dot q value 2 sin phi plus cos phi. 2 sin phi plus cos phi, what will be having there? So input is vector, output is scalar. The next part, what you can have it as curl. So I told you that three important thing we have in the electromagnetic fields: gradient, divergence, and curl there. So the last two parts what we can see for the gradient and divergence. The next one what we'll be having is for the curl here. Okay, so normally the curl, what it gives there? It normally gives the maximum circulation of that vector over the area, as the area tends to 0 there. Okay, so the curl F we can represent it as del cross F. Gradient means del F, divergence means del dot F, grade curl del cross F. Curl is how we have to take del cross F. So what is a simple thing what we can have? Curl indicates a measure of the tendency of the vector to rotate or twist. What curl indicates? It's a measure of the tendency of the vector to rotate or twist there. To rotate or twist. That what we will be having it for curl there. That what we will be having it for curl there. Okay. So you will be getting del cross A equal to 0. For curl vector, for the irrotational field, what we will be having? Del cross A equal to 0 there. If the answer we are getting that curl of the vector is 0, then we can say it is irrotational. For solenoidal, what we have? Del dot A equal to 0. Similarly, for curl, what we can have it as del cross A equal to 0. Del cross A equal to 0. So that corresponds to what we will be having it as irrotational field. That corresponds to what we will be having it as the irrotational field. Okay, that's what we will be having it for curl there. Okay, similarly, we have it for all, we will be having it the determinants actually, we will be having that one for curl. Del cross P, del cross F, and del cross Q. Okay, so for different coordinate systems, we have this one there, del cross F, del cross P and del cross Q there. Okay, for Cartesian system, cylindrical system and spherical system. Cartesian system, spherical system and cylindrical system. This is the thing what we'll be having that one. Okay, so once again we have dealt with the curl problem here. Once again we have dealt with the curl problem. So you can see that one on seeing the coefficients, we have to identify whether the system is cylindrical system or Cartesian system or spherical system. I see that one we are going it, the vector is a rho a phi a z. So I am saying that system is the Cartesian system and I am solving that one. Sorry, cylindrical system, and I am solving in that form of del cross Q there. Okay, and finding out that result part there. Finding out that result part. The result part you can see that one. Output is also vector here. In curl, what you will be having? Output is also vector. So in curl, input is vector, output is also vector. Whereas in divergence, input is vector, output is scalar. Gradient, input is scalar, output is vector. So because the more students will be getting confused along with these three parts there. So clearly see about that things here. Then basic theorems you will be having with the divergence theorem and Stokes theorem. So the volume integral of the divergence of the vector is equal to the surface integral of that part. What you will be having that one. Then along with that, the yes, we are seeing about these things. Then we can now enter into the basic concepts. What do you have it as Coulomb's law? Okay, we will be having with that Coulomb's law there. Okay, so the force between the charges. The basic classes you might have studied about the Coulomb's law. Okay, so force between 2 point charges is directly proportional to product of the charges and inversely proportional to the square of the distance between them. This is the basic concept what you might have studied there. Okay, so F is proportional to Q1 Q2 divided by R square. Q1 Q2 divided by R square there. Force is directly proportional to product of the charges and inversely proportional to square of the difference between them. So now we can represent them in the vector form. Now we can represent them in the vector form. This is the basic form what you will be having that one. So the proportionality symbol we can have it as constant of proportionality K, which is equal to 1 by 4 pi epsilon, where epsilon is called as the permittivity of the medium. Epsilon is what we call it as the permittivity of the medium there. Okay, by epsilon equal to epsilon naught and epsilon r. Epsilon naught and epsilon r there. And epsilon naught is what we call it as permittivity, absolute permittivity. Okay, by 8.854 into 10 power minus 12. And epsilon r value, relative permittivity, its value depends upon the medium used. Its value will be depends upon the medium used. So epsilon r equal to 1 for R medium, and for different medium it will be values will be getting different. Okay, this is the basic thing what you will be having there. When you are present with the vector form. So the last one what we have seen with the normal form there. This one what we see with the normal form. Okay, so in the vector form we can represent in terms of R vector, F vector equal to K into Q1 Q2 divided by R square into R12 where R12 vector is the unit vector. R12 vector, AR12 vector we can have, or R12 cap. So that R12 cap will be the unit vector. Unit vector. So normally unit vector, what is the formula for unit vector? That vector divided by modulus of that vector. If you are AR vector, so how we can take that unit vector? R vector divided by modulus of R vector. R vector divided by modulus of R vector. What you can have it that AR12 that. Then this is the basic form of what you will be having that one. Okay, so force equal to K into Q1 Q2 divided by R12 square into AR1. R12 unit vector there. Okay, so always we have that one, that force is F2 equal to minus of F1. F2 equal to minus of F1, that you will be having that concept there. Force on one path from 1 to 2 is always reverse from 1 minus 2 to 1. Then you know about that electric field. Electric field is nothing but force as the region it would acts at. It's a region where the force it acts. It will be denoted by E. We can say that force per unit charge. Force per unit charge. What we call it as electric field intensity. So E equal to F by Q. E equal to what will be having it as F by Q here. E equal to F by Q. Force per unit charge. So electric field equal to F12. Normally you know the force K into Q1 Q2 divided by R square into AR12, and E vector equal to F12 divided by Q2. F12 divided by Q2. Or F, already you know that at F12, if you substitute that value, you will be getting Q1 divided by R square. K into Q1 divided by R square into AR. So that electric field equal to Q1 divided by 4 pi epsilon R square into AR vector. It is volt per meter. Volt per meter. This about the thing what will be having it for electric field. Okay, the basic thing is what will be having for electric field is only Q. Whereas when you go for a force, you will be getting it as Q1 Q2 divided by 4 pi epsilon R square. That's a basic difference. Okay, Q1 Q2 divided by 4 pi epsilon R square for force. Whereas for electric field, only Q divided by 4 pi epsilon R square into AR. Okay, you will be having that thing here. Then when you go for electric field intensity due to various line charges, sir. Electric field intensity, now we can go for that one. Okay, so far we have seen with the basic concepts of, the curl, divergence and gradient. Curl, divergence and gradient along with the different coordinate systems. We have seen that things there. In here, you will be having with electric field intensity due to several point charges. Electric field intensity due to several point charges. You will be having test Q1, Q2, you can see that one. Q1, Q2, Q3, Q4, Q5 up to Qn we can have. If you want to find out the electric field intensity, you want to find out Q1, Q2, Q3, Q4 and Q5. These are all the several point charges. For that, we have to find the electric field intensity. So this is what we call it as superposition of, principle of superposition of charges. If you have several point charges, from the several point charges, we can find out what is the electric field at one point. That what we call it as principle of superposition of charges. Okay, so this is the format what we will be having that one. So the vectorical addition of all the charges will be equal to either E1 plus E2 plus E3 plus etc. up to En. So total electric field equal to 1 by 4 pi epsilon naught summation I equal to 1 to N QA divided by Ri square. into AR vector. Okay, so here the model problem relate with your force and electric field. We can see that one. So find the force on charge Q1 at 20 microcoulomb at 0, 1, 2 due to Q2 of 300 microcoulomb at 2, 0, 0 meter. Okay, so you want to find out the force there. So what is the force formula you will be having? Q1 Q2 divided by 4 pi epsilon naught R12 square into AR12. Just now I have told you. If the distance they have given us 5 meter, you don't want to go for AR12. Straight away the distance you know, R value you know, straight away you can substitute. But here they have not given in that format. What they have given us 0, 1, 2 and 2, 0, 0. That is in points. They have given you in terms of points. So what you have to do there? F vector equal to Q1 Q2 divided by 4 pi epsilon naught R12 square into AR12. So that AR12 equal to R12 vector divided by modulus of R12. AR12 equal to R12 divided by modulus of R12 vector. Okay, so that R12 vector, we have to find the distance between first charge and the second charge. The basic mathematical concept. If you have 2 points, how to find the distance there? The vector format we are finding out there. Okay, so the first preference we have to give to which point is where the force we are going to find out for that point charge. We are going to find out the force on Q1. So I am given first preference to point for Q1, that is 0 minus 2. What will be having there? Plus 1 minus 0 plus 1 minus 0. That. Similarly, you will be having it for R12 here. Then what is that 2.45? It is nothing but modulus of R12. A small mistake we have that. Sorry for that one. We have not represented with the modulus symbol there. The modulus of R12. It's what we have it as 2.45. Then if you substitute that one, you will be getting the value of F there. Q1 value is 20 into 10 power minus 6. Q2 is 300 into 10 power minus 6. 4 pi into epsilon naught 8.854 into 10 power minus 12. Then R12 square 2.45. You will be having it as minus 2ax plus ay plus az divided by 2.45. That F value. Then for that F value, if you take the modulus, you will be getting that one. Minus 0.733 square plus 0.366 square plus 0.366 square. Then we have to take the root. So many students you know about that one. From the vector point, if you want to find out the resultant scalar, you have to take with that modulus symbol there. Okay, root along with that concept there. The next one we will be having with that electric field intensity. The last one what we have seen with the force. The next one what we will be seeing with the electric field intensity. Okay, so in the electric field intensity of 1 point due to point charge what they are given. Electric field intensity of 1 point due to point charge. So E equal to Q by 4 pi epsilon naught R square into AR vector. Okay, so that here you will be having AR vector equal to R vector divided by modulus of R vector. R vector divided by modulus of R vector. You know about that one. Okay, so from P point minus Q point will give you the R vector. Then if you take modulus, you will be getting that modulus of R vector. So total electric field will be R vector Q divided by 4 pi epsilon naught R square into AR vector. So E equal to totally you will be having 5 into 10 power minus 9 divided by 4 pi into 8.854 into 10 power minus 12 into epsilon naught R square value there. Then if you want to find out E value there, E equal to minus 186.7 AX minus 66.6 AY plus 93.85 AZ. Here you can see for electric field you will be getting only one charge, but force you will be getting with the two charges. Okay, so some of the students they will be searching for another charge. Some of the students they will be searching it for another charge for that Q also. For the electric field also they will be searching it for another charges. There you will not be getting that charge in there. So E equal to for Q by 4 pi epsilon naught R square into AR vector to AR vector. Then next one you can see with this principle of superposition of charges. Just now we have seen. You see a model problem here. Here you will be having here we can have with that. Here you can see that one. We are having the square of side 3 centimeter here. Okay, so the positive charges of 100 nanocoulomb are located at the three corners of the square. You can see the three corners 1, 2 and 3. Okay, so we can find out the electric field intensity at the fourth corner. We have three corners 1, 2 and 3. There we have charges 100 nanocoulomb. So if you want to find out the electric field intensity due to 1, 2 and 3 at the electric field intensity at 4, how we have to do that one? That's what we are seeing here. Okay, so Q by 4 pi epsilon naught R1 square into AR1 vector from one point to another point. Similarly with that Q by 4 pi epsilon naught R2 square into AR2. Q by 4 pi epsilon naught R3 into AR3 there. For individually we have to find out the vectors, and if you finally if you add you will be getting these things. So the total electric field equal to Q by 4 pi epsilon naught into that the same concept what you have done here. The same concept what you have done for the normal electric field. Okay, this is about the thing what you will be having that one. So far in the today class we have seen about the basic concepts of these things. And we have different charge densities. When you go with the different charge densities, we have line charge density, surface charge density and volume charge density there. Volume charge density. Okay, so about these things you can see it in the later on sessions. You can see it about these things in the later on sessions. Also about we will be seeing about electric field intensity due to infinite line charges. Electric field intensity due to infinite line charges and all these concepts you will be seeing that one. Finite and what are the how the electric if the electric field is due to infinite fine charge, what will be that value of electric field at one point. Similarly, if you are the circular disk, what will be the if the circular disk is having full of electric charges, field charges, what will be the electric field. Similarly, if you go for that infinite sheet of current. Similarly, if you go for infinite sheet of current, what will be the charges? All these things we can see it in the later on sessions. Okay. Thank you, Pa. Thank you.
Thank you, sir.
Thank you, Ma. Thank you.